Here's a very quick demo about finite element analysis. I'm going to use Inventor, and I've got a little part here that I want to see how much it will bend if I push down on this little dot, straight down, or if I push sideways on this little dot. And I want to see how much it will bend. And so I'm going to use finite element analysis. And basically what that does is this cuts this into tons and tons of little pieces, and it uses vector analysis to put it into a state of static equilibrium. In other words, it's pushing and the internal stresses are all balanced out and it can't move anywhere. That's how much it will bend. Right? And so CAD gives us a lot of opportunities to do this. So I'm going to go into my stress analysis tool. It's not something I want to do by hand, not something I could do by hand. And I'm going to create a study. And by the way, I've assigned this as being aluminum, a type of aluminum. So here we go. I've got it up and running. I've got this assigned as aluminum. The first thing I need to do is say, where am I going to hold this? If I just push this in midair, it'll just float. So I'm going to find a constraint, and I'm going to use this nice big back plate as a constraint. And then I can put a force on it. So click, and I want to put a force right there. And I'm going to put like something not too big. I'm going to put like 20 pounds pushing downward. Okay, so that's sort of what I'm going to try there. And once I've got a material, how it's being held, and what I'm doing to it, forces, pressures, twisting, things like that, I can simulate it, and it's going to do its thing. And there it is. And it says red is where it's the maximum, so there's the most stress down here. And you can see it does bend. It doesn't bend that much. Let's see how much it bends. In the displacement, it just wants to show you what the shape is. It's going to bend only 0.00961 inches. Sorry, 0.012 inches. Okay, about very, very small amount, less than about 1/100th of an inch. Okay, so I can do all that, and then if I want to change this force and see what it does in the other way, so I can take pictures and I can do all sorts of stuff here, but I can remember that this is 0.012. I can get rid of that force. I'm going to finish that analysis and come back and fix this back end again. Let's create a new study and fix the back end again. And you can do there we go. Let me get that right. Fix the back end and come back over here. Now I'm going to put this force pressing sideways, and my amount, I'm going to do the same amount, 20 pounds. And let's run our simulation now. And now we can see it's going to bend that way, but how much will it bend? Ooh, 0.18. So this is really good for us to be able to compare how an object will work when you push it or pull it in different directions. I can put lots of forces on it. I can do lots of things to it. But that tells me, of course, that it's stronger in the up and down direction than it is sideways, which we know. We know that just from our experience. of pushing and pulling on things. But the FEA gives us actual real numbers. This thing goes into static equilibrium after it's bent about 0.18 inches in the small direction and 0.012 in the other. And finite element analysis is the way we get it. And we're going to use the program called Inventor. SolidWorks has it, Fusion has it, Rhino has it. This is not anything that's special to Autodesk. We just happen to have Autodesk products available to us, so that's what we're using. But the engineering and design world runs on finite element analysis to ensure that your parts flex the right amount, don't get too many stresses, and that the safety factor is okay. And it's all done by finite element analysis.